When you think about it, your code only does three things, right? It allocates some memory. That's what a variable is doing. It's allocating some memory of some size and representation. You're then reading that memory and you're writing to that memory. I mean, basically, this is all you're doing. You're allocating, reading, and writing. But the funny thing is, I don't care what the type is. At the end of the day, especially on these machines that are in front of you, what you're really doing is just reading and writing integers all day. Everything boils back down to an integer or a floating point number, especially if you're doing your GPU, ML kind of stuff, right? But everything kind of boils back down to an integer. An integer read and write. These are integer-based machines. And so if you're looking to have the most efficient code possible, then you want to make sure that you're working with the most efficient integer for the architecture that you're working for. And so this is why you're going to see a lot of code using just int. So the compiler can choose the most efficient integer size for the architecture that's in front of you. So we're going to be building and running a lot of code on AMD 64. That's our 64-bit architecture. That integer will be a 64-bit int. That's going to be the most efficient integer. So that's the reason why I don't want you using precision-based integers until there's an API that is specifically saying, I don't care what the architecture is, we're locking ourselves into an integer of this size.